we have two presenters, Aslam, and myself. Aslam will discuss about how to become a meteorologist. Aslam is a PhD student in applied meteorology. He also has many years of experience in meteorology field. He worked with the Nigerian Meteorological Agency for many years. So Aslam is here to tell us how to become a professional meteorologist, step by step. Okay. Uh, here I can invite Aslam. If Aslam is here, you can come forward to start. Let's welcome Aslam, please.
I will tell you that question here. I'll tell you when to share it. The mic is there. Hello. Okay. Hello, everyone. Good evening. Hi, everyone. As the earlier introduced me, I'm Anslem by name. PhD student, as he earlier said. And today I'll be speaking on the pathway of becoming a professional meteorologist right from experience. But before then, I want to share a brief story actually. That is my own pathway actually. Yeah, I think sometimes let's say 10 years ago, so I came back for my first course on meteorology. So to me, then I felt that I was so good that I can actually give a better focus of the yeah. So I went home. I went to my home country. So I met my grandmother. So I was there with my grandmother. Then after about some few hours, then my grandmom now said, Muslim, please go and pick up the clothes outside. I said, why? She said, it might rain soon. So I looked at her. I said, grandma telling a trained meteorologist that it will rain. Instead of me to tell her that it will rain. So I was like shocked. To me, I said, no, grandma, it will not rain. But grandma still insisted that, look, young man, this will come in within the next 2 hours. So I said, okay. Then I picked the clothing in. Behold, within the 2 hours, it actually came, the rain came. So I was like, this woman, how come I'm trained, she's not trained, and she got the right forecast? So I was kind of ashamed of myself. So she won 1-0, isn't it? But that was my first training as a meteorologist, meaning that I have not been, I don't really have the experience at that time, isn't it? I just learned the ABC of meteorology, not knowing that meteorology is not just about the lettered word, but meteorology, it comes with what? Observation. She's not educated, but over time, she had observed the weather condition. So she could actually predict and tell you when a storm is coming, maybe via thundering activities, maybe via sound and everything, then via maybe through low clouding. She might have seen it over her years on Earth. But for me, I went to school, I got trained, but I still lack experience. So grandma was a better forecaster than me. I said, okay, let me give myself some years, then I'll still come back and challenge grandma. So let's see how it goes in this our story of becoming a professional meteorologist. So that was my first setback actually. Move now, meteorology by the okay. Yeah, okay. So meteorology is a Greek word that that was given by the scientist Aristotle. The word meteora means occurrences in the sky or atmosphere. Occurrences in the sky and atmosphere. So it's actually a Greek word, meteorology. So the word meteor is occurrences in the atmosphere, and the word logy is generally the word used for study. Studying things is the word logy. So at my footnotes here, I said what? I said we are all meteorologists by default and by we are all meteorologists unknowingly. Oh, okay. Let's flash back. When we are kids, actually, there's this popular songs that we sing when we are kids. Anytime we play around, then we look up in the sky, and the sky turns probably cloudy, or the winds is coming so fast. Then we sing this song. Then rain, rain, go away, isn't it? Rain, rain, go away, come again another day. Little children want to play. How does those kids know it wants to rain? It has not started actually, but they saw a cloudy sky, low cloud, high wind speed coming, then the winds blowing here and there, and they started singing, rain, rain, go away. And it has not started, but they knew it will soon come. So we all here, we are all meteorologists by default, because we, one way or the other, knew when it might rain and when it might not rain. But that is far that's a far tale actually, because meteorology properly entails more dynamics and other things. So let's move. Grab the microphone around so that we can pass the microphone, because actually this class should be interactive actually. So I have this puzzle actually. I want us to interact here. Oh, I would have loved it so I can move around. Okay, so I have this puzzle right here. So the first puzzle here is that, okay, I said here that hammer is for carpenter, then the whistle is for the referees. Then what do we have for meteorology? Using these first two samples. Dash is for the meteorologist. What is for the meteorologist? If hammer goes for the carpenter, whistle goes for the referee, what is for the meteorologist? Please, the microphone, please go and stand here, please. Give it to them. Let me hear what is for the meteorologist, please. If hammer goes for the carpenter, whistle goes for the referee, dash for the. Give it a shot. We're all okay.
Maybe weather.
No. What's
Anyone?
what is the tool? What tool do meteorologists work with? Hammer is a tool for the carpenter, isn't it? They use the hammer to work. why the whistle is used by the referee to work, then what tool does the meteorologist use in their work? Weather is not a tool.
Observation.
Weather is not a tool, isn't it? Then what tool do they use in their work? Please, someone should get this. We're all meteorologists. Online people, check online. Are they speaking? Eh?
No, we are not speaking. We are
Unmute the
listening.
meeting and answer.
Okay, I can just question.
Observation.
Okay, okay, yeah. So the online people can also unmute and you can just say something. Is she speaking? She said something. Sensor, like to sense your skin? No, there's a need for it. Popular thing we use. Okay, here. Come again. Yeah, somehow there, but there's a word I'm actually looking for. Goods, data, just the word. Data is our tool. Data, D-A-T-A, data. Bottom is the singular of data. D-A-T-U-M is the singular form of data. D-A-T-A is the plural form. So is the word I'm actually looking for is data. Meteorologists cannot do anything without data. If not, then what are you doing? You are doing nothing. So, okay. It's not moving.
Story.
It's not moving. Okay. Is it post? Is it post?
No,
It's okay. Okay, it's okay. So, okay. Going by the topic of the course is that becoming a professional meteorology. So we are going back to our high school days. So what course or what subject do you guys think is the best or is more connected to the professionalism of meteorology? No, hold on, don't rush. Then we pass the mic round. Give me three, the first three, the topmost. I think that is so connected to meteorology. That's the first three. Okay.
So the first three, I think it will be chemistry, not chemistry, mathematics, then physics, then I think will be geography, I guess.
Next person. Nice one. Nice one.
I guess it's geography and physics and mathematics.
Another person. Quickly, I need like two mics. Someone should be here with a mic. Someone should also be here with a mic. Another person. Another speaker. Okay. After this slide, then share the keyword. Any other speaker? Who is okay? Okay.
Yeah, I actually think geography.
Okay. No other person. Okay, someone is here, please. No, you can speak loud if your voice is loud enough. Geography, mathematics, and chemistry. Nice one. Nice ones. You guys actually tried, but all of you added geography, isn't it? All of you added geography. Then the irony of it is that geography is not even amongst the top four here. It's not even among the top four most connected course to meteorology. It's not. Okay, let's see the top four here. Starting from what? Physics, mathematics, chemistry, biology, geography, and maybe you can keep HSK. Do you know why? See, actually, when I was in school, when I was in the high school, I actually thought geography was even the main course. That was what I thought. But when I verged into the profession, I saw that geography was not even there at all. It's not even part of the top four. Geography is just like a historical course, history of geolocation. Understand? Physics is the major meteorological course. That is why other definition of meteorology is atmospheric physics. That's why people call it atmospheric physics, because meteorology deals with the atmospheric nature of physics. Then the mathematics part of it is the application of physics, because without mathematics, you cannot get your physics, isn't it? Then the chemistry part of it is also there because of the gas laws, the aerosols, and everything. Understand? That is why the chemistry is part of it. Then the biology part of it is about the agro part, the agricultural part, that is the plant life and other things. That's why the biology part of it. The geography part of it, it is also good actually, but it's not the topmost. The geography knowledge is good for you to actually know the geolocation, to actually know mapping and other things. It is also necessary. Then the HSK part of it, is it part of our work? Is it part of our work? Okay, nice one, because we are in China. So let's see why. Now, look at these laws of motion. Newton's law of motion is the most powerful law that connects meteorology, which says what? Your force is equals to mass product of acceleration, isn't it? Good. So this equation, this is very simple actually, but is the most powerful equation in meteorology. In a way that you know that before weather will take place, there must be particle motion, isn't it? There must be particle motion. Something must move before weather will take place. There will be instability. Something must shake something for weather to occur. That is why this law is so precious. This is the famous and the most important law gathering concerning meteorology. That's why physics will always come top, followed by the mathematics part of the physics, then the air parcel, everything into the chemistry parts, then the biology part. So, President, kindly share the QR code. There is this questionnaire that was prepared. So I want you guys, please take up your phone. You have to, let's get some statistics from the questionnaire. Yeah, start from question one. There are 4 questions. Do the first one first. So after they answer the first one, then you send the second one. Then is this shared to the group? Okay, please check the group, please. It's been shared to the group, to the career guidance group, isn't it? Yeah. So kindly answer it. When you are done, then the next code will be shared. Have we shared it? Okay, share the second code. Second code. I think the second code is there now. Okay, share the third code. That will come be first. Okay, the final code, please. Okay, let's just give them like 1 minute so that they'll be done with the questions before we move on. We're going to assess the statistics of the question at the end of this first session. Okay, guys, so let's move on. Now, let's delve into the professionalism of meteorology now. In the work of becoming a meteorology, you could either be an operational meteorology or you become a research meteorologist. We that we are in NUIST, we are basically research meteorologists, especially most of us here, we are research meteorologists. Those that are in the offices are professional meteorologists. So let's delve into each of them one after the other. So let's delve into the operational meteorology. Even the operational meteorology is also sectioned into two parts. We have the observation and we have the forecasting. That is the operational. So for example, we have the NASA. You know, NASA, all of you use their data. NASA, those that are here, they are operational meteorology. Those that work here in NASA, they're operational meteorologists because they generate data and they also give forecasting. Then we also have the NOAA. Those that also work here also work as operational meteorologists. They generate data and they also give forecasting. Then this is the CMA, as the China Meteorological Administration. They also generate data and they also give forecast. And we have the WMO. The WMO does virtually everything. They give forecast, they give observation, they also give the standardization of every meteorological standard. They provide it. And they also go into investigative research about the future and the projection of the operation. Then we have the popular one, that's the ECMWF. Those of you that use ERA 5 and ERA Interim and other things, that office, they are also operational because they also give observation and they also give forecasting. And that is my office actually. I also give operation, I also give observation, I also give forecasting. So now let's see how the observers work. Where and where do they get their data from? So first of all, it could be ground observation. It can also be upper air observation, which some people also call the pilot balloon. So you being an observer, you can walk like this man here. He goes into the observation. He picks some parameters ranging from temperature, dry and wet bulb, humidity, soil temperature, and others. This man gets it from the ground observation. Then we have the pilot balloon. How this work? How many of you have come across this actually? Hmm? How many of you here have come across this apart from the big men here? Do you guys know how this works? Huh? Yeah, just very few of you I know. Very few I know. This is called the pilot balloon. So what this does is that the balloon is being pumped with a very light gas. Like, what is the lightest gas on Earth? Eh? Helium or hydrogen? Eh? Yeah, yeah, hydrogen, isn't it? So it's being pumped in with it. Then it's being attached with a sensor office, and is being allowed to go up into the air. As it goes up into the air, it takes the observation of every level, every atmospheric level. That is from the 850, the 700, the 550, 400, till it will get to a point that the balloon will do what? What will happen to the balloon? Speak up, please. What will, it will disappear. Okay, now let us go back to our chemistry class now. As soon as you go up, yeah, what happened to the temperature? The temperature, yeah, it decreases, isn't it? Then what goes on with the volume as soon as you go up? Yeah, gas law, yes. The volume what will increase. So as soon as the balloon goes up, it keeps what expanding, isn't it? As soon as it keep going, it keep expanding, then it will get to a time that it will exceed the elastic limits. Now we have come back to the physics. It will exceed the elastic limit and it's what? It will burst. This balloon will burst. Then this sensor falls to any part of the world. It will not be gotten back. That sensor is lost. So it is a one-time work. So as soon as you send this back, you cannot get the sensor back because as soon as the balloon bursts, it's lost. But the sensor sends the observed data back to the computer. As soon as it is going up, it's sending the observed data at every level it goes. The 950, the 850 HPA, the 700, the 600, when it gets to the elastic limit and it explodes and it terminates the operation. But at least before then, reasonable data will have been gathered. So this is another way to get your data. Then after these two men and these other persons get their data, they send their data into this room. This is the collection room. Then you can also get your data from the satellites, from the ship, and from any other place. But the major thing that everything comes to this office. This office is called the collation office. Everything is gathered into this office. For what? So let's move and see what happened in the office. This is the office. So everything gets to this office. This is NOAA's office in the US. So everything that happens here, both the ground observation data, the pilot balloon observation, and every other observation that has been gathered comes into this office. For what happens in this office? This office is where they all sit down here. That is, the forecasters sits here. They all comes here and talk about the gathered data. They discuss they can even argue. They analyze the data, the output, and come to a consensus conclusion on what has happened and what is the implication of the data.
No, your project is the same. Mm-mm.
Is someone speaking?
Yeah.
Someone speaking.
Oh,
Any
sorry.
question?
No. Continue.
Okay.
Mm.
So after that, what's happened now is that these guys here are the presenters. So they take the conclusion here and take it to the television and tell the world what these guys have agreed on. So these guys comes here and pick the final argument, because here they actually argue in this room, which we also do. We argue, no, it won't rain, it will rain, no, the temperature. We actually argue every day in my office at this room. Then after getting to the final concession, these guys comes here and pick the final agreement, and they go to the television and tell the public what has been agreed upon. This other man will come and tell us when the code will end, but I'm not sure this code will end anytime soon. So looking to the end of the winter, not soon. So please, let's not even maybe in the next 2 or 3 months before we start putting on this jacket. So this is what happened between the observation down to the forecasters and down to what the public consumes, because the output is here, what the public actually consumes. Now, what happens here? What happens here? What makes these guys a professional meteorologist? One is that they argue the argument that actually goes down here. The argument that actually goes down here is based on one experience. Then the knowledge of your immediate past weather, then what is actually going on now, the knowledge of your present weather condition. These are what they argue on. So now let us look at the first one. Let us look at the first one, which talks about experience. In the past 70 years, when I was not even born. So she was arguing based on her experience. So experience actually counts in becoming a good meteorologist. Then your knowledge of what happened yesterday. That is why it is always very good for we meteorologists to always observe properly. We should observe properly of our environment. We should always look at it so that we can tell what the next day could look like. So they argue based on experience yesterday and what is going on presently. That is what they argue. So now let us look at the present argument. What did they use to argue presently? So they argue, this is their argument, past, present. The present is based on the dynamics on the atmosphere. Like the dynamics means maybe the winds, speed, strength, and all that things. The instabilities, that is the temperature, the vertical velocity, and other things. With this, they can actually come close to what they can actually come close to what could happen tomorrow. They might not be 100% correct, but they can actually come close to what could happen the next day. Then let's see what's the weather chart. Let's just see some sample of the weather chart they argue with. Now, let us look at this simple chart which they argue with. So looking at these charts, well, what are their interests? Where and where do they focus actually? What part of the charts do they actually look at? Because based on their experience, they don't just come and start to look here and here and here. They, first of all, they can go very close to where they see tight gradient, where there is close gradient, which is here. You can see the isotopes here. Here is closer than here because here is what? Wider. So they look at where the lines are quite tight, very tight. Like here is quite tight. They look at here compared to this other part that is kind of wider, but here is quite clear because it's just like you saying it's just like you putting this kind of long steps and you putting kind of this step. So it means that this my last step is closer to my first leg than this other one. So definitely there must be interactions here and it might actually instigate weather. So they don't just go and look at it. So their main focus is looking at the tightening and seeing the concentration. So now let us now look at the tightening and also look at the temperature. So you can now see that here that we have a lot of tightening, that is where the temperature is also very high. So it's quite straight. Those are the things they look like. Then another chart that is very good, another chart that is quite good is this high and low pressure chart. This chart is very good for rainfall prediction, especially because, okay, do we mean by high? High is what? High is when you have outflow. There is outflow of winds or any other event. High variable is, high pressure system is when there is outflow, and you have low system is when you have inflow. Winds are flowing in, and when they flow in, they cause what? They cause instability. So forecasters look at where they are high and where they are low system. So definitely the areas that has the low will definitely has more rainfall, and places that have the high, it is quite simple. So those are the things they look at directly. This is not, we are not going into the real work. This is just the basic of what actually goes on in the discussion room. Now, let's move into the, okay. So now let's move into the other aspect of meteorology. Now, this is the research. This is where we all like the research aspect. The other one is for operational, for people that work in the Met offices. So yeah, we have a lot of areas here. We have the areas where they do the field and the laboratory research. That is those that are into agromet, those that plant to see well how the plant goes from the planting stage and to the last stage of planting. Then we have the methodology and the data and the data set evaluation. That is where most of us are. That's because most of us do a lot of statistics. Most of us use a lot of AI, the machine learning and others. Then we have the modeling. That is where some of us are too. That is the work cost one other kind of modeling. Then we have the geometeorology. That is those that are into the methodology and evaluation, because all of us here love to get data sets, compare, find the relationship between this, between 5 or NASA, of find the relationship. So we do more with the second option. I know. That is what most of us here do. Then after doing all this research, how do we communicate it? How can we tell how can we tell the world what we have seen or what we found? We can only tell them through the publication, through our publication, through books, through seminar, and through this platform which we are. Okay, so we can actually tell the world about what we found through our publications, through seminars, and through IMSA platform. Now, what are the basic basic errors that we found during the research? The basic errors that we can encounter during the research. So, or the part of it, that one that I said that is the most common one, that is the evaluation, investigation, and the implication research, because that is the field which most of us are actually doing. We either evaluate data or see if this data performs better than this data, or we do the implication research to see what caused this, or or what are the effects of this kind of research for the public. So what are the things you need to know? First, you should know your data. You should actually know your data. You should know if your data is 2D, 3D, 4D, 5D, or other Ds. Please, can we who can like describe the content of the 2D and 3D data set for me? 2D, 3D data sets for me, please. Who can differentiate them for me? 2D, 3D data sets? Can anyone? 2D, 3D data sets? None of you? What's the difference between 2D? Okay, yeah. Any other person? 2D, 3D, 4D, 5D, and there's even 6D now. So who can just, okay, let's start from the 2D and the 3D. Any other person apart from him? Okay, so the simple way to explain this is that the 2D is just 2D means two dimension, that is latitude, longitude, that is the 2D, lat long. Or you can say data at a point. Data at every point means what? There is latitude and there is longitude for you to have data at a point. That is the 2D. Then the 3D, you will add one other variable. So that means the 3D should have what? Your longitude, your latitude, and maybe time, making it 3D, isn't it? That is time of occurrence. Then the 4D, you will not add one other, yeah. Then there you can have your latitude, your longitude, your time. Then you include your pressure levels. That is your pressure level made it the fourth one. Then the 5D, what are we adding to the 5D? Yeah, most of you are just checking online. I know, I saw them. Hmm? Variables, you just checked online. I saw you. Good. Variables, then the 6D is what you can add what? Is assemble, So, the more you add, the more. So first of all, you must know your data. Then the other one is that you must read articles. You must read articles. When I mean you must read recent articles. Why recent? So that you could see where the research and to also see where there are gaps to be filled. So you must read articles, a lot of articles, especially the current ones, so that you can actually see where there are gaps, so that you can actually fill those gaps. Then another error that could be made, don't just making random work, is that during your comparison, that is statistical comparison, especially those of us that do maybe correlation, regression analysis, trying to compare two things, understand, you must be sure that the data sets, they are of the same resolution. You must put the data sets on the same resolution, because it's just like me. It's just like me. Please, can I use somebody for for one practical? Who can I use for an example here? Volunteer, please. Just one person, yeah, that is not as tall as I am. Maybe shorter person. Just come, please. Let's just do it so that you can understand what I'm trying to say. Come. Photographer, come over. Okay, no. Okay, stay. Mm. Yes, let him come. Yeah, President, come. Let's just do some practical. Okay, so yeah. Mm-hmm. No problem. So you can see that this guy is bigger than me. Hmm? So for us to fight, this guy will beat me up, isn't it? So I cannot be compared with him. But for him, at least we are of the same. I will fight him. So yeah, that is what I meant by you cannot compare two things that are not of the same resolution. Understand? You must compare like things. You put them on the same resolution so that there will not be bias, isn't it? Because if for me to fight him, there's already a bias. Then another thing so another error that could be made is that during your plotting, when you are plotting your graph, you don't just plot with any color. Don't just plot anyhow with any color. There are specific colors for parameters. You cannot just use yellow and plot rainfall. You cannot use yellow and plot precipitation. It's not understand. So there are specific colors for met plotting. So you can go to this guy's book and check out some colors meant for meteorological plotting. This guy. Then another thing that you should also add up in your work is that every work should have limitation because no research is perfect. No work on earth is 100% perfect. So every work should have shortcomings. So you must definitely add your shortcomings in your work. You also add the implications in your work. Then you also add your recommendation in your work. That makes your work a bit okay for publication. Then you must know your data attributes. Here, you must know the type of data you have, whether they are short or float, whether they are string or they are double. You must know your data. Again, you must also know the properties of the data. Just like I said, you must first know the total grid size of each data, and you also know your X and Y points of the data. You should also know the most important one. You should know the resolution of your data, both the temporal and the spatial resolution. You must know that of your data, and you should also know how the variable name is being spelled on the data set. And how do you know this? You must use the most powerful tool in the processes, which is called, you can use the CEDO, or you can use NCDOM minus H and your data. It gives you this, but most of us here uses this. So here, look at what this gives us. Look at the boards. We have the grid size. The grid size is 30,951. Then we have the Y size. That is when I mean the Y size. The Y size are sizes from what? From the east. No, from the Y size. That is okay. The Y size is from the north to the south. Why the X size are points from the east to the west. You must know this for your data. And the most important one is the resolution. That is the X ink and the Y ink. You must know the resolution. Like this data set, the resolution is actually 0.1. The resolution of this data is actually 0.1. And but here it is what 0.009. For any reason, it was short here, but converting this, you will get 0.1. So what are the X and the Y sizes? Let's see how they are here. Yeah. These are the Greek point actually. This in each, this is the, this is the longitude. No, this is the latitude. Then the east to west is the longitude. So at every Greek point, at every box, there are other points in at every box. Just like we said last, just like this here, look at this exercise here. Here we have 181, isn't it? And the Y size is 171, meaning that the X size has 181 points on the X axis. Then the Y size has what? 171 points. Now, look at these points here. So here I brought out this point out. Just one of the boxes was brought out. Then look at the number of points per this box. Who can tell me the total number of Greek points in this box? That is the total number of Greek points in this box. Who can tell me? It's quite simple. If you just count this and count this, then you times them. That's the number of points here is how many? 36, isn't it? Yeah? Is it not 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6? Then by the time you 6 times, it's 36, it's 5, 6. So each point, so it means that this point that I just brought out here, so that means in each of these is 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. Then similar goes here, 1, 2, 3, 4, 5, 6. That is what just displays. So this week, this thing that I just showed you was what, this is just the counting of this, of the total, that's the total Greek size. But in this data is 30,951. That is the total Greek size. But in this case is what? 36. The total Greek size here is 36. Okay, so now based on this, I want us to based on this evaluation, investigation, and the implication is such. So here we have 3 categories here: evaluation, investigation, and implication. So I want you guys to catch this and see and tell me which of these applies to each of the articles I will show you now. Whether the article is evaluation article, investigation, or that of the implication article. So let's go to the articles and see. So this first article here, Is it evaluation, investigation, or implication article? The title alone has even given you the answer. Is an implication article, isn't it? Meaning that here the authors investigated the implication of the cyclone on mainland China. So it's an implication article. Then this other publication, is this a evaluation, investigation, or implication article? Please talk now. Give them the microphone, let them speak. Is it evaluation, implication, investigation article? Yeah, investigation. Because this article investigated, it's investigated what aerosols causes on the precipitation, isn't it? It's an investigation article. Then this other article, is it evaluation, implication, or investigation? In fact, the title has even said it. So this is what evaluation, because it's very simple. So here, what they did was that this was done by our boss, Aminu. So he evaluated different data sets on know the best. Good. Then let's go on to other article. This was done by Jonah. So is this implication, evaluation, or investigation? Huh? I think this is implication because it's saying weighing. It's trying to weighing the fluctuation, isn't it? So he's investigating. This is from Matthew that just left. Okay. This has even spelled it all. Is was implication. This is an implication article. Then this has also spelled itself out, isn't it? Is evaluation, isn't it? Good. Okay, so now let's move on to the next. So the first one we did was for statistics research. Now let's move on to the tougher one. That's the models. Understand? So in this case, what kind of research can be conducted with this? Mainly, it is all maybe sensitivity testing. So here, yeah, most of the authors want to test the best scheme, the best configuration, just sensitivity examination. That is what most of the common research over this area does. So this is what makes your modeling good. Yeah, I want to go into the details because most of you here are not that familiar with atmospheric modeling. So this is, then what is atmospheric modeling? So let me just give you the brief story about atmospheric modeling. Let's use this. Let's use this equation for the explanation of atmospheric modeling. So up there in the atmosphere, there are some things that your eyes cannot see. A lot of things. They are all governed by equations. So here there are some equations that takes care of the atmospheric dynamics. Then the first equation is the equation of momentum. That's why I said meteorology is more of physics. Is definitely physics, because everything that goes on in the atmosphere is physical equations. Eh? What is that? Is it the bachelors? The bachelors are more here now. Yeah. So yeah, I want to not tell you why you need to understand this equation, but here you don't you don't need to will I say that you don't need to perfect it, understand, because modeling has done has converted it into simple arithmetic. Modeling has turned this vector science, everything into your minus, your plus, and your division. So yeah, that is why we use numerical methods to convert this. So let's see how this actually works. So this is the first equation in the atmosphere, then followed by the continuity equation, followed by the, the, the thermodynamic equation, and followed by the water vapor equation. But then the last one is the gas equation. Yeah, that is the equation of states, which can be also called the gas equation. Yeah, these are the equations that actually govern the atmosphere. Now, what do models do to these equations? So when I have my models, like example, like the WRF model, like the Cosmo model, like the Chinese grape model, like the Rex CM4, CM3, CM5 now model. Then I input these equations into the model. What the model does is that it simplifies it simplifies these complex equations, the vector equations, the differential equations. It converts it for me into a more simpler and understanding one that the computer can actually understand. For this, it is bad because the computer does not understand this. The computer does not understand the atmospheric equations. So the model converts this into the language that the computer could actually understand. These are the ones that the computer will actually understand. Yeah. Which are the conventional ones? That is the plus, the minus, the division, and the times. So this equation is complex, is being turned into this. Then the computer picks it and work speedily with it, and it's now become numerical modeling. So all these large words are we here. Models, WRF model, Cosmo model, this is just what goes on there. That is the conversion of complex equation into arithmetic simplified equation. That is the whole noise about all this numerical stuff. So it converts it. So here the computer understands it and work with it. Though I will not go deep into it. Anybody that just want to learn more can maybe consult the president. So you can learn more of this. Like this class is just the basic. Here we will not go into it very deep. So that is all. Now let's see some of the publications that could actually come out from these atmospheric equations. Let's see some of the publications that can come out from this. This is a publication. Yeah, I don't know the author, but you guys know the author. So this work actually use all those equations you saw. This work use actually all those equations you saw to get this. Similar with this work, actually, this work actually compared the WRF PEM and the WRF physics. That was the objective of this work, to see how both of them can actually reproduce extreme rainfall episodes. Then this work uses Cosmo. They are all the same method. Both the Cosmo, both the WRF, the GRAPE, they are all about the same equations. So, and this other work, I don't know the author. This other work also used WRF to actually dealt with this. Good. Summary of all our longs and backstories that, like we said earlier, that meteorology is into two parts, both the operation and the research. But both of them interact. The operational guys gives data to the research guys. Then the research guys gives what? Their publication back to the observed guys so that they can step up their observation. These guys cannot work without the data coming from these guys. Understand me? Because these guys work with the data from either NOAA, NASA, so they could either work with this data. Then when these guys are done with their work, what I mean by these guys, I mean you and I and you and you and you. We are the research teams here. Then we send it back to the public through our publication terminals and through this same platform. References for this school. These are the guys you can actually meet in case these guys are guys that has worked in operations actually. They work in their national operations. Yes. You have me, you have Aminu, you have Matthew, you have Ima, you have Kai, you have Tamirat, you have Jonah, you have Dereba. A lot of guys in this school are actually good with operations. So in case you have more things to know, you can actually meet any of them for more explanation. I might not be perfect. I'm not perfect. I might not have explained it all, explained everything very well, but you can still ask other guys for more detail. But as I said before, in case you have any issue in the areas, especially investigation, research, implication, evaluation. Yeah, you can still ask more questions then. So that it is good to actually know the area you actually want to delve into, so that your work could be very fast and straight, than to just keep thinking, what area do I go into? Greenish, please, can we publish the questionnaire? I know. Rounding up now. Can we let's talk on the questionnaire. It's taken off. Can it be out? Is it here? Okay, so let's go through the questions again. The first question says what? Yeah. What was the first question, please? Someone should speak out on that. What kind of hazard?
Yes, the question reads, what kind of hazards do you experience in your country?
Okay, thank you very much. So here, the percentage shows that it is more of flooding. So what is the consequence of flooding? That is excessive rainfall. So definitely you should think about this and know that there are gaps in that area to also work. Extreme rainfall should be your target over your area, because now the voting says that flood is common in most of our areas. Then the second question is, when did you hear about the word meteorology? During high school? Are you guys serious? High school? Are you sure it's high school? 50%, something 67%. That is so high. High school. Hmm. Hmm. That is not to me, because what I've seen in this school is that most of them come to me and say, Aslim, I don't know what to do, because I just came to this school and I found out that this school is meteorology. So, I understand. So, how come this kind of number heard about it? Okay, so let's go on. So, let me not argue with the statistics. So, the third one is that what ministry or part of your of your country's government or department is, and okay, is Department of Meteorological Services. So many say, okay, aviation 16%, defense military 7.5, agriculture 9.5, environment 45, and I don't know 21. So environment is okay. Then the fourth one, then is okay. So the fourth question, what was it again? I can't remember. Okay, the first question is, if I'm close, I don't see.
Fourth question reads, what aspect of meteorology do you think you can relate better with, or can be combined with your current research field?
All right, thank you very much, the online guy. So from what I see is that a lot of guys went for climate change and dynamics Anybody went for? Wow, I'm so impressed about this. The first one, the atmospheric physics, that is my area. So that's why I'm so impressed. Physics, that means we are on track. That is good. So, all right, guys, I think this is where we will draw the curtain to a close. Thank you.
Thank you very much. You just teach. Teach. You teach.
It's okay.
Yeah. Good. Thank you very much, Aslam. My name is Amin. I think you all know me. Uh, I also work with the Nigerian Meteorological Agency, Nigeria. Not exactly 10, but about 10 years of experience. And also work as a meteorologist. So for me, I'm going to discuss about the opportunities, which I believe everyone is waiting to hear about what are the opportunities in meteorology. And for the undergraduate student here, you don't need to study a meteorology to become a meteorologist at the undergraduate level. If you study mathematics, physics, chemistry, computer science, you can proceed with their masters at the in meteorology. Okay, like me, I study statistics during my bachelor, and for my masters, I proceed with the meteorology, applied meteorology, and climate change with management in the University of Reading, UK. So you don't need to do that. I just want to add, especially to undergraduate students. Okay. So for my presentations is not going to be very long. I just have some few things to discuss. Number one, we talk about the introductions of the opportunities in meteorology, and also why pursuing career in meteorology. Then we are going to talk about the job opportunities at the local and global level. Okay, then emerging career fields in meteorology, then essential skills for a meteorologist, those skills that you need to have to be able to conduct a research in relation to meteorology. Okay, then of universities, those universities that if you were get the chance to be there, you learn a lot. The real world success stories and the conclusion. So if I'm to ask you a questions now, why do you think meteorology is matters? Dr. Aslam has set a foundations, a very good foundations on those things that you need as a meteorologist. If I may ask questions, uh, why do you think meteorology is matters? Anyone? Why do you think meteorology is matters? You can read from the board. Well, part of daily life. Anyone?
Can you ask the question again?
Okay, anyone? Anyone from this side? So to have a look on the screen, you can see that the atmosphere is constantly in motion, helping our world. Meteorology is a key to understand it, okay? And meteorology is more than about predicting rain. It is about solving problems that affect life globally. and it plays a critical role in addressing climate change and natural disaster like wildfire, drought, and cyclone. You see, recently we experienced a very dramatic wildfire in Los Angeles, United States, where it take many people's life, destroy many properties, and it push people away from their houses. So meteorology also help in fixing and also providing early warning to such type of a disaster. That what literally make it very good and very interesting. And also sustainable development goals, the United Nations. Then why pursue a career in meteorology? If for those who are already who done their bachelor meteorology, if I may ask, why do you feel like you need to? Why do you feel like pursuing a career in meteorology is important? Anyone? Huh? It's more challenging, right? Yeah, of course, meteorology is complex because you have to learn many things to be able to work as a meteorologist. Huh? Yeah, exactly. Exactly. Thank you. In fact, people work. You see, your effort directly save life and also protect property. Your effort to protect people property. Okay, and of course, improve daily living, providing weather forecasts, prepare people against rainfall, against some other things related to weather, and also high job demand. With climate change and increasing extreme events, meteorology become more critical than ever. With the issues of climate change, the pressing issues of climate change, there is high demand of professionals who literally understand the meteorology, climate change, all this. So being a meteorologist is you may not find it very, very difficult to find where to work and get paid. Okay, we'll explore some job opportunities that you can see later. And of course, global recognitions. Working as a meteorologist, you can be part of this United Nations, the NASA, National Aeronautic and Space Administrations. Of course, National Weather Service, which we are all part of. And I believe we have many people here who are working with the National Met Office back in their country. So this is it. Then job opportunities, local and global. Let's begin from the local levels, okay? Government agencies. I think most of our countries we have Met Office. Okay, let's take some few. For example, here in China we have China Met Administrations, which this is the office, and also we have Nigerian Meteorological Agency in Nigeria. This is the head office for those who haven't seen the picture of Met Office in Nigeria. This is the headquarters where I and Aslam work. And to be precise, this very place, this is where Aslam works. They make it. So this is where Aslam actually works. This very numerical weather. Okay, so this is the head office. And for the Pakistan, This is the Pakistan Meteorological Department in Pakistan. So, and also in Bangladesh, we have this. This is the office in Bangladesh. So you studying the meteorology, you can go back to these places and work. And I believe if with the good reputation of this university, if you were able to to obtain certificate from this university, you may find it easier to get job at those places. Not only these places, there are many places. So disaster management authorities, of course, most of our countries, we have these offices where they handle issues of disaster management, like drought, flood, or some other disaster. So being a meteorology, you can be able to be there and work. Your case, you are professional. Then, in relation to agriculture, becoming a meteorologist, you can help farmers to adapt to changing weather pattern. Okay, if you can like more of consultancy, you can do some consultations to farmers, provide them with those information they need to farm and when to farm and how, what times exactly they need to farm this, something like that. So then renewable energy companies, those companies that they produce solar and wind projects. So you can also work in such type of places. You don't need to necessarily work at the Met office. You can work in these places. This one, usually you can do it on your own as a consultant. You have your own group, you register in your country, then you do consultations. Then we have university and research institutions. You can teach, of course, you can teach. How many people want to teach here after your graduations? You want to teach? Huh? How many people want to teach? I know most of the people, they don't want to teach. One, I can see two. Anyone? Hmm? It's okay. Teaching is not easy actually because you have to study again. After master's, you go for PhD. After PhD, most of you go for postdoc. Even if you go for postdoc, you go back, you have to continue doing research, apply for becoming a reader. After becoming a reader, associate professor, step by step become professor. So it's very challenging. So people don't like to teach, but it's good. For me, actually, I like to teach because I find it interesting. Okay, when you teach, you share your knowledge to people. I think it's something very good. Okay, you impact people life. So for the airports and aviations companies, you can also work in airports. Most of our Met office back home, usually we are very connected to airport. Like us in Nigeria, all the airport in Nigeria, we have Met office. So some countries, their Met office is not at the airport, but they provide weather service to the airport. So it depends. So being a meteorologist, you can work in the local, in your Met office in your country, in the airport, or other place. And also in the airport base, you see, some countries, they employ meteorologists. Those who study meteorologists are the part of their army to help them handle some issues related to meteorology. So you can be a soldier, an army, while providing weather services. I don't know about other countries, but I know there are some countries who does that. Then at the global levels, this is more challenging, but if you work very hard, you improve your CV, you make your CV very, very heavy, you can stand a chance to work at the global level. Places like World Meteorological organizations, you can work there. But for example, people who work at the Met Office back home, if you are a permanent representative, can maybe provide some support for you to be there. Sometimes it's easier to be at the World Meteorological Organization because sometimes they don't want to open it up, but it's somehow easier for people who work in the Met Office to be at the World Meteorological Organization. Then United Nations, you can also work with them, collaborate with them, things like that. And also Intergovernmental Panel on Climate Change, IPCC, you can also maybe sign a contract or something like that. Yes, so this is the, do you know this place? The picture here. Yeah? Yeah, the WMO headquarters at Geneva, right? Then how about this? This is UNICEF, and this one is the IPCC committee. And of course, you can work with space agency, for example, like NASA, European Space Agency, and the Indian Space Research Organizations in India for satellite meteorology. You can work also with NGOs and environmental group for climate adaptations and disaster risk reductions. You can also work in such places. And marine meteorology, you can also work with the maybe private companies or with government. But yes, being a meteorologist, you can be able to work in these places. Then, of course, a European Center for Medium Range Weather Forecast, you can also work in these places. It's not very difficult, actually. If you have the qualification and the CV they need, and you have a lock, you can easily find yourself there, because I knew a person who worked with WMO, start from the local level to the top level. So it's very possible. The main thing is for you to do the needful, work very hard, make things possible, study, publish many papers, learn many skills, then you pray. I believe you will be there. Then let's discuss about the emerging career fields in meteorology, those new areas. You see, we have climate policy and sustainability. Those are some of the emerging fields where you can maybe focus your research, advising those people who advise government and organization on climate resilience. Then renewable energy meteorology, helping optimize wind farm and solar energy generations. Data science in meteorology using AI and big data. And also aviation meteorology, which we just discussed now, is also a new emerging field where you can do your research and understand some. And then media meteorology, explaining weather phenomena to the public. This is also very interesting. Like UK Met Office, they have already adopted these things. And if you were very good in, let's say, media, you can speak very good English, you can easily get work in relation to this at the UK Met Office. So there are many opportunities actually. You just need to have what you can offer. The moment you hold that thing, you can offer something, then the sky is your limit. Essential skills. You see, to be a meteorologist, I just want to add this. Aslam has already said things related to this. You need to possess technical skills, the basic skills, not only read, solve mathematics, but you need to get some technical skills. For example, the programming part, the Python. You need to understand Python, how to program. Even if you can't write script, which I know most of the students struggle to write a script, but if you can read the script, is good. You see, with the ChatGPT, you can help you to write your script. Then you can read and see if you got error, you know where you can trace the error and fix it. So you don't need to, with the AI now, you don't even need to write the script yourself. But the main thing is to read. When you get error, you know where you can fix the error. So that is very critical as a meteorologist. You need to know the R, then the NCL, then MATLAB. This is some of the logo for these softwares. Of course, ArcGIS is very vital and good also for the geographical information system too. This is very important also. Then there are some soft skills. There are some soft skills that you need to possess. For example, communications or public awareness and scientific discussion. You have to be a very good in communications. Your communication skills has to be very, very good. Your communication skills, because, for example, maybe those who work with Met Office in their country, they may understand what I'm saying now. If you have to provide, let's say, some information to pilot, you have to be a very good communicator, because, like, you are trying to, small mistake can cause many problems, can affect people's life. So your communication is very important. You need to be very good. Your communication has to be very, very good. Then analytical thinking to interpret complex data set. Aslam just mentioned about the 2 dimensions, large and long, and the 3 dimensions, the time, that long, and 4 dimension, 5 dimension, etc. So you have to know those things. Then sometimes you can plot, yes, but how can you interpret what you plot? What you plot matters. Sometimes you can make a very good plot, it look very good, but the interpretation is a problem. So you need to understand how you can interpret those complex stuff. You have to understand them very well. So, sorry. Then interdisciplinary knowledge, you have to know not only in one place, you have to know some other related disciplines also. Then you have to understand physics, as Aslam mentioned, is very critical in meteorology. You have to understand mathematics, and of course they go together. And environmental science is also key. So now, the top universities, we talk about the skills. If you have that skills, then I believe if you are very good, you will be aiming good universities, right? Because most of these best universities, they look for best student. Not all students they take. So, Nanjin, if you are here, sometimes you will not understand that this school is among the top universities, especially in meteorology in the world. But if you are in, you may not understand. But those who are outside, when they say China, then Nanjing, they will cross their mind. That, oh, NUIST is, they know NUIST is very good in meteorology. So the top university that you can guide or push someone to go and study meteorology. This is not only, there are many top universities actually, but because of time, I just picked few to show you. But this is not only the top universities in the world. That's so for the first one, of course, I have to be selfish because I'm here is Nigerian University of Information and Technology, okay? Science and Technology NUIST. Is very good in meteorology, actually. Very good. And this university is one of the best universities in China and Asia for meteorology. Don't forget, I said one of the, not like, it is not the best, like, but one of the best, okay? Then the University of Reading is also one of the best university. This is the picture for the University of Reading. Actually, this is the Palmer Park. I think, yeah. Then it's also a very good university. I can tell you because I had my master's there. I can tell you that it's a very good university. They teach a very, you know, if you go there, you can't graduate just like that. You must learn many things, just like here. So it's a very good university. Maybe you can guide someone to go there, or you can go yourself and see. Then Massachusetts in United States, this university is also very good in meteorology. My friend Williams, he attended this university during his bachelor, and the guy is very good actually, very, very good. In fact, we are very close friends up to now. He lived in the United States, but I think his family originated from Nigeria, so that actually connects us together. So we become a very close friend. So the guy is good, and I know it's not only good; it's because of his background and knowledge he acquired in the university. So this university, they are very good actually. So in case in the future you have a brother to guide, or you want to, in your own, you want to go, you can try to go these universities. And the good thing, they offer scholarship. You can just search their names, the university names, just like NUIST. You will see their scholarship. You apply. If you are very lucky, you'll be selected. Then you go there and do your study. So you can just we share the PPT, of course. So you can try to search, maybe if you're a bachelor, you want to go to the Europe after your degree here, then you can try. If you are very lucky, you'll be selected. Maybe for your PhD, you can go. If you are PhD for your postdoc, of course, you can go. So it's a very good opportunity, especially in meteorology. Then we have University of Oxford in UK. They have been known for climate science, meteorology, and atmospheric chemistry research. They are also very good. You can try. And the University of Cambridge, how many people know this university? Cambridge. Everyone, right? It's a very famous university actually in UK. So if you got time, you can search their website and see their opportunities. Sometimes people feel like, no, even if I search, I may not get the opportunity. It's not true. Try. If you try, you can get it. Because when you hold your hand and said, I will not get it, you will not get it. But try. That small moment you take to apply may change everything. So don't try always to seize opportunity. Wherever you see opportunity, seize it. Use it and see what will happen. Okay? So this is it. Then let's look at the real success. You see, Aslam has tell us the story about the becoming a meteorologist, and I try to show you the opportunities of becoming. When you become a meteorologist, the opportunity you may come across. Okay, so let's have a look on a success story for people who have started from the grassroots and they reach the top level. Top level. They work at their Met office and they end up becoming recognized globally. For example, Gombele rose from a rural upbringing in South Africa, and she became the country's first black female meteorologist in 1987 in South Africa. She advanced through leadership role. She shaped aviation meteorology globally, contributed to Bilemo and ICAO. She earned multiple awards, not only one. She earned multiple awards, including Aviation Professionals of the Year 2019 for her pioneering, including Aviation Professional of this year for her pioneering contribution to the field. This is the source. If you have time, you can check this link. You will see more details about her. And they have been recognized by World Meteorological Organizations. And secondly, we have Christy Yang Yu. She's also a meteorologist, just like us, the way we started. And at the Hong Kong Observatory, she has contributed significantly to aviation's meteorology in Asia-Pacific region. As a young leader, she has fostered regional collaborations, led segment improvement, and chaired the Bilemo R2 aviation service team, and demonstrating excellent leadership, research, and international cooperation in meteorology. She started at local and she rose to the top level where she can be recognized globally. So you can also do the same. It's not impossible, it's possible. Everything is possible, and so you just have to try, okay? So being a meteorologist, there are many opportunities. And this is some of the example of people who have succeeded in their career. Claudia, she's also an aeronautical meteorologist, an Argentina Sabico. She has excelled in aviation meteorology, med QMS, and gender advocacy as an ICAO and Lemo expert. She has led global initiatives. You see, improving airport forecasting. For people who work in airport, they understand what I'm saying. And promoting gender equality. And of course, inspiring future meteorologists, just the way we are inspiring ourselves now. Collaborations and continuous learning. You can search her names and see more details about her. Maybe you can learn something from her career. We have Jennifer. She also succeeded. And also we have Andrea Anderson, a meteorologist with a bureau in Australia. And she has made a significant impact also in aviation, weather, and education. Starting in 2001, she contributed to the Bilemo initiative, working alongside influential leaders. And we have Dr. Yinka Adebayo. Actually, he's from Nigeria. He started as a class teacher, teach in some of the universities in Nigeria. Of course, he teach in Kenya too, before he joined the Bilemo. So you see, he started at the local level and he reached the top level. As a meteorologist, you can also get the same thing. For example, he reached the Director of Education and Training Office at the World Meteorological Organization. And he has extensive experience in scientific policy and advisory roles with PhD in geography. He has worked with UNEP and ADB and also WLMO since 1990. He has also lectured and published research in climatology and environmental science. Those people who work with the Met Office and they maybe know much about, like Aslam, he knows Yinka very well. They know Yinka. So he started from and he reached. So it's very possible for everyone to. Okay. Then we have Jim Carter. He also very passionate about meteorology. He also among the people who have succeeded and make a lot of contributions to the field. Then in conclusions, I just told you that my presentation is very short but interesting. Meteorology is not just about predicting the future. It is about shaping it. Whether you dream of solving global challenges or making global impact, meteorology offer endless possibilities. The main thing I want to emphasize is be the change you want to see. Be the change you want to see. Start with the sky. At the end, I want to say thank you for listening. So we'll share any questions? I haven't give room for questions. Any question? Any question? Okay, so we can share the code then.
Okay.
No question? Are you sure no question? Or you are tired?
Yeah, okay.
Huh?